Hello, in this section I will go over how to find the least common denominator, or also known as the LCD. So why do you need to know the least common denominator? Least common denominator is essential to finding the unknown variable in an irrational function. So maybe in the next section, in the next section you will learn how to solve equation in rational form like this one. 1 over x minus 1 plus 2 over x equals x over x minus 1. So you got to get rid of the fraction by multiplying all sides by the LCD. So that's one reason why it's important to find the LCD. There are other few reasons. Finding the least common finding the least common denominator is essential for adding or subtracting fractions. So for example, 4 over x cubed y plus 2 over x y cubed, you want to simplify it, you got to find the LCD. And it's also essential to simplify complex fractions. So yeah, those are the three main reasons why finding the least common denominator is important. Okay, so let's go over the steps of finding the LCD. So step 1, factor each denominator completely. Use exponent notation for repeated factors. I'll explain that when I do an example. Step 2, write the product of all the different factors that appear in the denominator. And step 3, on each factor, use the highest power that appears on the factor in any of the denominators. So once you have it in the most primest form, you want to put it in a power, and then you use the highest power. And I will explain that. That all makes sense when we do an example. Okay, so let's start with example 1. Find the least common denominator for the fraction or rational equation. Do not solve. So it says we just want to find the LCD because we are adding fractions, right? Oops, I don't like this color. How about blue? So LCD, let's look at our numbers on the bottom. We have 20 here, 12 there, right? It's not in the most primest form. So first we got to put it in the most primest form. So starting with 20, what two numbers multiply 20? 5 and 4, okay? And then you circle your prime numbers. So 5 is a prime number. A prime number is a number times 1 in itself. So 5 is prime. 4 is not. 4 could be broken as 2 and 2. Okay, so you have 5 as your prime number, and this 2 and 2 you can rewrite 2 times 2 as 2 to the second. That's how we want it. Okay, now let's do 12. 12 is not prime. 12 can be broken down as 6 and 2. 2 is prime. 6 is not. 6 could be broken down as 3 and 2. Okay, so on the right side you have 3, and then you have 2 times 2 is like 2 to the second. Okay, so that's how we want it. So on the left, 20 can be written as 5 times 22 second. And then on the right, 12 can be written as 3 times 2 to the second. So now let's find our LCDs. So what you do is look at each number. So let's start with the base 5. Do you see anywhere else with the base of 5 in the bottom? No, I have a 2 square here, a 3, and a 2 square, so it's not repeating. So just bring it down. Now let's look at the base 2. Do you see anywhere else in the bottom with the base of 2? I do. I see a base of 2 here and a base of 2 there. So the rule states if you have a repeating base, you pick the one with the highest power. But since they're both to the power of 2, just write it as 2 to the second. And then let's look at our last base 3. Do you see anywhere else with the base of 3 in the bottom? No, I don't. So just bring that down. So put it all together, you get 2 squared is 4 times 3 times 5, that is 60. Okay, so that is your LCD 60. Okay, yeah, let's move on. So we don't have to solve it. We just want to find the LCD. We'll solve it in the other section. Okay, example 2, find the least common denominator of the fraction or rational function. Do not solve. So we have a fraction, 1/4 plus 5/6. So let's find our LCD. So 4 could be broken down as 2 and 2. This is a prime, this is a prime, so 4 could be wrote in as 2 square. That's how we want it. 6 could be broken down as 3 times 2, so that would be like 3 times 2, right? So let's look, so these are our numbers, so let's look at our numbers. So let's look at the base of 2. Do you see anywhere else with the base of 2? Yes, I see 2 here, or 2 to the 1. So the rule states if you have a repeating base, pick the one with the highest power. So our highest power is 2 to the second. So you're going to use 2 to the second only. And then let's look at our other base, 3. Do you see anywhere else with the base of 3 in the bottom? I don't. So just bring that down. So put it all together. 2 squared is 4 times 3, which is 12. So your LCD is 12. Let's move on. Example 3, find the least common denominator for the fraction rational equation. Do not solve. So yeah, let's do this one. 2/5 minus 5/12. So put it in the most primest form. So 15 can be broken down as 5 and 3. 5 is prime, so it's 3. And then 12 can be broken down as 4 and 3. 3 is prime, 4 is not. It can be broken down as 2 and 2. So 15 is 5 times 3. Let's see, over here on the right side, you have 2 times 2 times 3. So 2 times 2 could be expressed as 2 squared. And then 3. So what is our LCD? So let's look at our base 5. Do you see anywhere else with the base of 5 in the bottom? I don't. So just bring it down. Let's look at the base of 3. Do you see anywhere else with the base of 3 in the bottom? I do. I see it right here. But since they're both to the power 1, you're just going to use the power 1, 3 to the 1. What about the base 2? Do you see it anywhere else in the bottom with the base of 2? I don't, so just bring that down. 2 squared. So put it all together, 2 squared times 3 times 5, that is 60. So your LCD is 60. Okay, let's move on. Okay, so example 4, find the least common denominator for the fraction or rational equation. Do not solve. This one's slightly different now. Now we're doing letters. Okay, so if we look at our bottom, we have a5b, a times b cubed. I think it's in the most primest form. You can't really break it down. So you have ab here and b1 here, and then over here you have a times b3. So your LCD is going to be, so let's start with the base a. Do you see anywhere else with the repeating base of a? I do. I see it right here, but you pick the one with the highest power, so it's going to be a5. And then let's look at b. Do you see anywhere else with the base of b? I do. I see it here, and I see it here. So which one do you pick? You pick the one with the highest power. So it's b3. Okay, so your LCD is a5, b3. Okay, so let's move on. Let's do example 5. So we have 1 plus x equals 1 plus x over 2. So it's a little bit different now. So is it in the most primest form? I believe so. So did you know that x plus 2 is actually one term? People think it's two term, but it's not. X plus 2 is actually one term. It's like x plus 2 raised to the 1. And then x is also one term. So it's in the most primest form. So let's start with the base x. Do you see anywhere else with the base of x? No, don't be fooled. This is x plus 2, so this is one term. So this really isn't just this isn't just x, it's actually x plus 2. So this is one term. So bring that down. Now let's look at the other base, x plus 2. Do you see anywhere else with the base of x plus 2? No, so bring that down. And I recommend do not foil it out, just leave it as it is. So your LCD is x times x plus 2. Okay, let's move on to example 6. Find the LCD of the fractional rational equation, do not solve. Okay, so we have this x minus 1 over x squared minus x minus 12 plus x plus 4 over x squared plus 5x plus 12. We do gotta factor it because we gotta put it in the most primest form. So let's factor it to find the LCD first. So over here, x squared minus x minus 12, we're gonna do simple factoring. So this would be factored out as x, and then 4 and 3. And this would be negative 4 plus 3. Okay. Over here, this will be factored out as x, and what two numbers multiply 6, and when added gives you 5. I'll use plus 3 plus 2, right? Okay, so now it's in the most primest form or the most factored form. Let's look at our base. So this is actually one term, this is one term, this is one term, and this is one term. And they're all to the power, I believe, 1. So let's look at the base x minus 4. Do you see anywhere else on the bottom with the base of x minus 4? I don't. So bring that down. Okay, now let's look at the base of x plus 3. Do you see anywhere else with the base of x plus 3? I do. I see it right here, right? So the rule states if you have a repeating base, pick the one with the highest power. Since they're both to the power 1, you're just going to say it's just x plus 3. Okay, now let's look at the base x plus 2. This is one term. Do you see anywhere else with the base of x plus 2? I don't. So you just bring that down. So this is your LCD, all this, and just leave it like that. Do not fill it out. Okay, I think I will stop here, and then we'll do part 2.